Okay, we've been talking a whole lot about measures of variability today. And we got this problem that we're looking at, and I want to use this as an example to work out with my students. It's a really good example, and I think that's a good real-life example for the students. And so I'm going to use this one to talk to them about a particular type of measure of variability. Now let's look at our situation here. It says the chart represents the number of songs in each classmate's playlist. Now I bet in my class right now I've got kids who probably have a personal device that has all kinds of songs on it. And I dare say that if we were to compare their data with the data in front of us, it would probably be pretty close. So this is a really good real life example. Now some of the kids apparently have a lot of songs. I couldn't imagine. 798 songs looks like the most. And then there's one poor kid who's only got 13. Probably somebody went in, hacked his phone, and deleted all of his songs or something. Who knows? Maybe he just got it. We don't know. Anyhow, it says which measure of center, the mean or the median, is best for this data. Now when I look at this set of data and I see that I've only got, well, it's a 3x5 chart, so there's only 15 values here, and it goes all the way from 13 to 798. That is going to be one wide set of data. And because it is so wide, it's so widely dispersed like that. You have some that have one has in the teens, then you have some that have in the hundreds. That I think the best measure of center for this one is going to be looking at the median. I think that looking at the median would be the best choice. If we were to do the mean, then the mean would give us an average that would be misleading. Because once you found the mean or the average of that set of data, it would look like the kid who only really has 13 might possibly have as many as 200. I haven't found the mean of this set of data, but it's possible. And then you would have a mean absolute deviation that would be way off, way off. So on this one, I think it would be the median. And to find the corresponding measure of variation, I would do the interquartile range on this. Because the interquartile range is going to tell us how far apart, about 50%, be like kind of like the second and third groupings when you do your quartiles, would fall in that interquartile range. And then we'll talk about what those measures tell us about the data set. Now the first thing I'm going to do, anytime you want to find the median, is you have to take your data and list it in order from least to greatest. So I'm going to try to get a piece of paper here. And I'm going to list my data in ascending order from least to greatest. Okay, so my lowest value, like I already said, is 13. And then it looks like we have 28. Now, boys and girls, if I make any errors, you jump on, okay? Let me know. My next value, 35. My next value, 45. My next value looks like it's going to be 54. And then 64. And then 65. And then it looks like we have 81 and 87 and a couple 97s. I guess we'd have found our mode if we needed to. And then it goes to oh, thank you for pointing that out. Then we got 245, and then we've got 456. And 700, and then we've got 798. Okay, so we have got such a wide range here. I mean, just the range itself, if we did just a basic range, it looks like it'd be about 785. That would be the range. And that's a huge range when you look relative to the data that we have. I mean, that's huge. That's absolutely huge. So, now to find the median of this set of data, we need to figure out the middle data point, the middle value. Now, we already established that we had 15 values in this data set. To find the median, you'd say 15 plus 1 is 16, divided by 2, and you get 8. So the 8th value is our median. Alright, so 1, 2, 3, 4, 5, 6, 7, 8. So our median is 81. So our median is 81. Now, in order to find the interquartile range, what we're going to have to do is find the first quartile and the third quartile. We find the first quartile by looking at our lower set of values and find the median of it. And so we have, since this is the 8th value, we know that we've got 7 values here, 7 values here. So 7 plus 1 is 8, 8 divided by 2 is 4. So our 4th value in each upper and lower sets is going to be our median form. So 1, 2, 3, 4. So our first quartile or lower quartile, 45. 1, 2, 3, 4. Okay, 245 here is going to be our third quartile. Now, to find the interquartile range, we have to subtract the first quartile from the third quartile, and 245 subtract 45 is 200. So our interquartile range is equal to 200. So that's a, relatively speaking, that's a pretty hefty interquartile range. So what this tells us here is that the middle half of the data is extremely spread out. I mean, when you look at this set, 45, 54, 64, 65, 81, 87, 97, 97, 245, is very spread out. Now, I have to say, if we hadn't made this big jump here, if we had another 97 or something, it might not look as spread out. But since that value, which is pretty high, it's a big jump from 97 to 245, it's so big, it does show us that we have quite a range there. It's pretty spread out, that middle half of the data. So those classmates have a great variety in the number of songs on their playlists. I mean, some kids have just a few songs, and some kids have more songs than they could sit and listen to. They did it all summer vacation, perhaps. I don't know. All right, so now if I were to say a math practice that could go along with finding interquartile range, I would say I use what I know about finding the median of a set of data, and then I use what I know about finding the first and third quartiles, and then I just use what I know on how to find the interquartile range. I mean, we're to that point. We've got these skills, and now we're just having to combine them and apply them.
David, come to the office.
You kids have worked on range before. You kids have worked on median before. You kids have worked on first and third quartiles back when we did box plots. So this is not anything new. It's just a new way of using what we know in order to interpret data. So I hope this little video helped y'all.